In this video, we're going to start talking about kinematics in one dimension. Now, in general, in this whole unit, we will be talking about things like vectors versus scalars. We'll discuss what is distance versus displacement. We'll talk about how to calculate average velocity and do problems that have to do with relative velocity. In this particular video, we're going to discuss two of those things, vectors versus scalars and distance traveled versus displacement. So let's start our discussion by talking about vectors versus scalars. Now, scalars are quantities that only have a magnitude, meaning they only have a number attached to it, versus vectors that have magnitude plus the direction. For example, something like force. When I'm talking about force and I say I'm pushing on a box with a force of 5 newtons to the left, force will always have a direction. Whenever we talk about force, the direction always matters because it matters whether I'm pushing that box to the left or to the right or up or down. So we always need to include the direction, which makes it a vector. Now, what about a scalar? Mass, for example, cannot have a direction. It doesn't make sense to say that something is 5 kilograms to the left or 5 kilograms to the right. So therefore, mass is always going to be a scalar. So just to sum up, scalars cannot have a direction and vectors always have a direction. Now, I want you to think about the rest of these quantities, starting with something like velocity and speed. So speed, you're probably familiar with the term from everyday life. For example, in the cars, we have speedometers. Speedometers tell us how fast the car is moving. 50 miles an hour, 60 miles an hour. Hopefully you don't go over that speed limit. But it doesn't tell you the direction. Therefore, there's only a number, right? 50 miles an hour, but with no direction. Velocity would be like saying I'm moving 50 miles an hour north or I'm moving 50 miles an hour south. So velocity is similar to speed, but the only difference is that it has a direction. Now, what about time? Can time have a direction? Hopefully you answered no, because time, again, it doesn't make sense to say that you're moving 5 minutes to the left or 5 minutes to the right. Time only moves in one direction, right? Time can only be positive number. That is the difference between vectors and scalars. And it's going to be really important that you understand it when we talk about our today's topic, which is distance versus displacement. The formula for distance traveled is simply adding all the distances that you travel together versus displacement, which is a vector, which is final distance minus initial distance. Let's say, for example, I start at my house and I walk 10 meters to the right of it. Then I decide to come back 10 meters back to my house. Firstly, what is the total distance traveled? What is the total distance that you walked? Of course, the total distance is always going to be just the sum of all the distances that you covered, 10 plus 10 or 20 meters. What about the displacement? Now, the displacement is how far away your initial point is from your final point. Since you came back to exactly the same point, your displacement is 0. Now, you can also think about this in the following way. This 10 is positive if we're talking about the displacement because it's pointed to the right, and this 10 would be negative. Because in physics, we take usually to the left and down as negative directions. Then if you add this 10 and minus 10, the overall displacement is going to be 0. But essentially, displacement is how far you are from initial point, and you came back to the same point, therefore displacement is 0. That's the difference between the two. One is a scalar. You always add these numbers. One is a vector. You can sometimes add them or subtract. Great. Now let's do one of the practice problems to calculate distance versus displacement. Right here we have Alice that walks 3 kilometers east from her home and then 4 kilometers south to the park. Calculate both the total distance Alice walked and her displacement from home. First, let's talk about the total distance. The total distance is going to be very simple. You just add 3 and 4, and it's going to be 7 kilometers. So in total, she walked 7 kilometers. Now, the displacement is going to be the distance between where she started So her initial position and her final position, where she ended up. You can probably see already that this is going to be a right triangle, where we're calculating the hypotenuse. If you remember the Pythagorean theorem, it says that hypotenuse squared is equal to 3 squared plus 4 squared. If we're solving for the displacement by taking square root of both sides, we get that displacement is 5 meters. Great. Now, I want you to try the next problem by yourself. See if you can get it. It's going to be a very similar problem, but now instead of Alice, we have Alex, who decides to explore a triangular park. She walks 100 meters east, then follows a path running directly north for 120 meters. Firstly, we have to calculate the total distance Alex walked. What do you think? And while you think on this problem, I'm going to have some water. Hopefully, you answered that it's 220 because you just have to add 100 and 120 together, which is 220 meters. Now, what about the displacement? Now, the displacement is going to be her initial position to her final position right here, which is, again, just like in the previous problem, going to be a problem where you have to calculate the hypotenuse of the triangle. Delta x squared by the Pythagorean theorem is equal to 100 squared plus 120 squared. Or if we square root both sides, we're going to have approximately 156 meters. Now, the third part, the angle between her total displacement and the eastward direction. In other words, the angle between here, the displacement, and east, right here. This angle right here is the one that we're looking for. Now, you really are just solving for the right triangle, where you know the hypotenuse, you know this side, and you know this side. We can use SOHCAHTOA. Say that tangent of theta, if you remember your SOHCAHTOA, the TOA part says that tangent is the opposite side over the adjacent, where this is the opposite side to the angle and this one is the adjacent. Therefore, tangent of theta is equal to 120 meters divided by 100 meters. Or, if I want to cancel out tangent and solve for theta, I'm going to take inverse tan of both sides. Theta is equal to inverse tan of 120 over 100, which is equal to 50 degrees as our final answer. Great. Now, in the next video, we will go over what is the average velocity and what is the average speed and how to calculate both of those. So please keep watching and keep practicing on your way to an A. Thank you guys for watching as always.